We all have heard about matter, but have you ever heard of antimatter? In the universe, everything is made up of matter, from the sun to the interstellar dust, and you and me. So basically, everything is made of protons, electrons, quarks, and occasionally some rarer particles like muons, thyons, and neutrinos. All these particles are, at their most fundamental levels, excitations in the everywhere permeating quantum fields. But these particles have identical evil twins. They have essentially the same properties like mass and spin, but opposite charges. So when they meet, they annihilate each other. It's kind of like how x squared is equal to 9 can have two answers, 3 and -3. And when they meet, they annihilate each other. Every fundamental particle has an antiparticle. Like muons have antimuons, thyons have antithyons, and electrons have antielectrons. But we also call them positrons. Since photons have zero charge, they're their own antiparticles, kind of like how 0 is equal to -0. So since these twin particles are so similar, they can combine just like regular particles do to form antiatoms, antimolecules, so basically anything from anti-ants to anti-Matterhorns. We can also make this really cool positronium ion, which is basically a hydrogen atom, except the electron, instead of orbiting a proton, orbits a positron for a nanosecond until they annihilate each other. Since regular particles and antiparticles annihilate each other so quickly, we've only been able to make and contain a few hundred anti-hydrogen atoms at a time. When these regular particles and antiparticles annihilate each other, a lot of energy is released, which is why they have been proposed as bombs or rocket fuel. But naturally occurring antimatter is very hard to come by. So unlike a uranium fission bomb, where you just release the bottled energy of a supernova that forged the uranium in the first place, you would have to put all the energy into the bomb yourself by making antimatter, which we can do by agitating empty space into pairs of matter and antimatter excitations. It's kind of like hitting 0 with a hammer to get 3 and -3, except instead of a hammer, you would use a particle accelerator, or high-energy photons of light. As it turns out, matter is very closely tied to antimatter. The mathematics of relativistic quantum mechanics predicted the existence of antimatter years before it was actually discovered. The fact that there's so little antimatter to be discovered in the universe is three things. First, an obvious thing, because if it were there, then we'd all have been annihilated a long time ago. Two, a good thing, because again, it would have annihilated all of us. And third, a very puzzling thing. Because if the matter and antimatter are identical mirror images of each other, then why did the Big Bang produce more regular matter than it did antimatter? No one knows, but to physicists, the answer matters.